Welcome to our final panel today on water in our industries. My name is Ronan McGovern, and I recently graduated from Professor John Lienhard's laboratory here at MIT. The first topic we're going to tackle today is water and energy, and I can guarantee that this presentation will be fluid and powerful. To address this topic, we're very lucky to have Mr. Michael Hightower. He is a distinguished member of the technical staff at Sandia National Labs and an expert in this topic. Please welcome, with all your warmth, Mr. Mike Hightower.
Thank you. Thanks, Mike. So how do I get this presentation up? Are they going to do it? All right. Thank you very much. It's nice to be here. Glad that it's no snow for us that came in from the west. I was asked to kind of give a kickoff of this session, Water for Industries, and Ronan asked me to talk about electric power generation, thermoelectric power generation. So I'm going to talk about some of the issues that we see emerging over the next several decades, and then finish up with some opportunities and changes and suggestions for industry and for the students here in the audience on research areas that they might pursue as they move forward. I think this is some really interesting times from a technical standpoint as we begin to transition our energy infrastructure in ways that are more sustainable and address natural resources much more appropriately. So real quickly, supposed to talk about electric power generation, thermoelectric power generation. And I don't know that a lot of people outside maybe the water industry understand how much water the thermoelectric industry and sector actually withdraw and consume on a daily basis. So this is data from 2000. The reason I haven't updated it, the 2005 data was almost exactly the same. And then we heard this a little bit earlier this afternoon that the 2010 data just came out 2 weeks ago, which actually shows a little bit of a reduction in water withdrawals in the United States over the last 10 years. Part of that was because the study was done during a drought. Part of it was the way that they analyzed some of the data. And some of it showed the actual reductions in the sector of most interest is the electric power sector actually dropped their water withdrawals by about 10%. So what we're seeing is that changes in water supply are beginning to impact the water sector. But if you look at this curve, the energy sector, both in the freshwater production withdrawal and saline water withdrawals for power plants that are on the coast, is the largest water withdrawal sector in the United States. 1 out of 2 gallons withdrawn in the United States on a daily basis is for electric power generation. So the next thing that we talk about when we're here in a group of water professionals is withdrawal is one thing, consumption is another. So even though the thermoelectric sector is the largest withdrawal sector, in other words, water withdrawn, in many cases that water is withdrawn from the water body, goes through the power plant, goes right back into the receiving water body, generally at something on the order of 20 to 25 degrees higher temperature. But it doesn't consume a lot of water. Some of the technologies, though, do consume. Evaporative cooling for power plants do consume a significant amount of water. So from an overall water consumption standpoint in the United States, the thermoelectric sector uses somewhere on the order of 4 to 5% of the water we withdraw on a daily basis. Now, the data that I show here is from 1995. And the reason I use that is that that's the last time the United States did a survey of water consumption. So anybody out there that's interested in water monitoring, water modeling, water resource observations, this is an area that's very fruitful that we need in the United States. Trying to base decisions on data that's 20 years old is really not that good of a deal. But the point is if you look at thermoelectric cooling, about 1/4 of all the non-agricultural consumption on a daily basis in 1995 was for the thermal electric sector. What we're seeing is with the change in power plants, change in regulations by the EPA, that number could double or triple if we're not careful, which would make the thermal electric sector, the energy sector, the largest non-agricultural water consuming sector in the U.S. in the next decade or two. So we're at the point where we're looking at an industry that when one withdraws a significant amount of water today, two could consume a large portion of our non-agricultural water consumption. So that puts this sector in direct competition with all other resources. And as we look at water supply availability, when we're looking in the U.S. at the water stress that already occurs, that puts the electric power sector in direct competition for significantly diminishing water resources. And that is the big issue that we need to look at on this water energy nexus, if you will. I have data here from 2003 from the GAO and 2013. What they show are the states. States in red or pink in 2003 are those states that have regional or local water stress as identified by water managers. The 2013 data shows the blue and the light blue states are states that are showing water stress. A couple of things I want to point out, that the stress across the country in water availability is growing. States like Illinois and Iowa have now, and Michigan, are seeing water stress. Other states like Washington State, Oregon, Florida, the Atlantic coast states like North Carolina, South Carolina, are all seeing water stress at a local or regional level. So what we're seeing is that this is not a southwestern U.S. problem. A lot of people say, well, those guys in the West, they don't have a lot of water, they ought to understand it. We're seeing water stress in a lot of other areas. Competition for industrial development, for population growth, and thermoelectric cooling are all in competition for these limited water resources. So as I mentioned, if we're looking at new power plants and directions in regulations and policies that make the water consumption out of the thermoelectric sector even larger than it is today, there are some concerns about how we can securely provide and reliably provide power in the future for long-term economic growth and development. I just wanted to mention, we're seeing a trend already in increased water supply stress in the U.S. We're expecting to see increased stress due to climate change. Earlier this afternoon, some people talked about that water was going to be the big issue with climate change. I have a quote here from one of our senior staff, our senior climate scientists. Some of you that are a little older understand this. This is, water is where the climate change rubber meets the road. That was I think a Firestone or Goodyear commercial about 30 years ago. Some of you in this room probably weren't born then, so you don't know it, but some of the older people understand it. So the point is that water is where climate change is really going to have its biggest, probably natural resource impact. And if we look at that, so we're already under stress in the U.S. in many states. We're seeing potentially increased stress. Anything brown is on the order of 10 to 20% reduction in surface water precipitation. And some of that could double in some regions, the amount of runoff that you are reduced. So the point is, we're going to have to look at all these competing uses for fresh water much more closely, specifically from the energy sector. Also, I want to point out with this slide is that this is not a U.S. problem. Just like it's not a southwestern problem in the U.S., there are many regions of the world that are going to see the stress associated with climate change from water availability. Mostly the mid-latitudes, but that includes, Southern Europe, Northern Africa, the Mideast, India, and China. In the Northern Hemisphere, and in the Southern Hemisphere, Brazil, and in Argentina, Australia, Southern Africa. Those are a lot of the countries that are expecting to have large economic development and increased issues with water availability. So their energy infrastructure is probably going to be stressed and potential for conflict as a competing demand for water resources. This is just an example of what we've seen around the United States in the last 4 to 5 years. Every circle on there is an energy site that is seeing impacts of water availability on their operations. And some of these sites, in Southern California and Arizona, some of them are concentrating solar power plants that use the thermal electric cycle and use water for cooling. Impacts on renewable energy. There's impacts on nuclear energy, fossil fuels, coal-fired power plants. So a lot of the thermal electric sector is seeing water stress already impacting operations. Again, across the country, issues that we have to address if we're looking at long-term economic growth and sustainable environmental development. One of the things I want to mention is even though some states have local supply demands for water, power plants generally, central power plants, have a large water footprint in the county that they're in. And so this curve or this graph just shows where there's projected to be new power plants going in the next 25 years or 20 years or so. And you can see, this is by county, so you can see that there's some very significant water impacts in many of these counties across the U.S. Counties that are already stressed in many cases with water supply availability. The blue is withdrawals of about 1 million gallons of water a day. The red is withdrawals of 50 million gallons of water a day. So you can see not only in the West, but parts of the Midwest and even the East, some places are looking at local withdrawals of 20 to 30 million gallons of water a day, competing demands for those areas. So without some changes in the way that we look at energy development, we look at cooling for thermoelectric power plants, number of potential conflicts that could occur across the country. This was a study done by Argonne National Laboratories for the National Energy Technology Laboratory, looking at power plants that are at risk of supply limitations and demand changes from other competing demands. You can see that it's not southwestern power plants that are more at risk. It's generally the eastern power plants. So this is a U.S. problem. It's a northeast problem, a southeast problem, Midwest problem. I think that we're looking at needs for technologies that address this in a number of different climate scenarios and ecological areas. So real quickly, there are some things that we can do. We can change some of the major water consumption for the thermoelectric sector is for consumption in cooling. If you look right here, this is water consumption for the cooling process. This is water consumption in the rest of the processes. Essentially for thermoelectric power plants, the cooling process is the largest water withdrawal or water consumption process by about 90% of all the water in the thermoelectric power plants used in cooling. So differences and changes in cooling technologies could have significant impacts and improvements in water consumption as we move forward. I'll just mention here real quickly a couple of examples. If you look at thermoelectric cooling for a coal-fired power plant, something on the order of 300 to 500 gallons of water per megawatt hour. If we transition to different fuel types, let's say combined cycle natural gas, we're looking for closed-loop cooling, something on the order of half as much water consumption per megawatt hour of energy. If you look at some of the renewable energy systems, they're close to zero, wind and solar photovoltaics. Concentrating solar can be fairly high if you don't do things like dry cooling. Unfortunately, dry cooling doesn't work that well in the deserts where you would generally put a concentrating solar power plant. So there are some concerns about how we accelerate the utilization of low carbon technologies for electric power. but don't unfortunately shift the burden, environmental burden, to high water use intensity. One of the things I wanted to show here on integrated gasification combined cycle, this is coal gasification with a combined cycle power plant where you can take the CO2 off as a stream that you could use as a benefit rather than as a waste. You can see that for that type of system, pretty efficient from a cooling standpoint. You need some water for the gasification process, but that's significantly lower than using a standard pulverized coal plant with carbon capture and sequestration that increases your water demand for carbon capture and sequestration by almost a factor of 2. So there are changes that we can make in the technologies we use. There's changes we can make in the processes that we use that I think in the future will allow us to really improve water use efficiency and sustainability. Here's another curve that's done by a group at NREL, looking at the different types of cooling technologies for different types of thermal electric plants. The point that I want to make here is they can be all over the place as far as water consumption. So maybe as we move forward, we should be looking at technologies that, one, are low carbon emission as well as low water use. A number of technologies out there, a number of opportunities to make improvements. Also, what we're looking at and what we're seeing is we're doing a study that I'm showing here for the Department of Energy, looking at water availability in the western U.S. We're in the process of doing this for the eastern U.S., just trying to identify for power plants other sources of fresh water. Can we use degraded water, wastewater, brackish water? And we are putting together, and this is on the web under Water Atlas, is access to brackish water, wastewater, and other types of water resources, such that we don't have to use fresh water and we can use other types of water resources for cooling. One of the things that I see is going to happen a lot, earlier they talked about desalination this afternoon. Desalination is growing at about 10% a year. Wastewater reuse is growing at 15% a year. We have some facilities in the United States. This is the largest inland desalination plant in the world. It's in El Paso. This is one of the largest national desalination research facilities. It's in Alamogordo, New Mexico, anywhere in the world. So we have some world-class facilities that can be utilized to use and test technologies that address non-traditional water resources and their utilization for things like thermal electric cooling. Currently, they're a little bit more expensive than traditional technologies, but there's opportunities for research to really address that, reutilize and utilize brackish water or water cycling within the power plants to improve water use efficiency, fresh water use efficiency. DOE just put out this report. I think that's a very good primer on energy and water. You can go to just type in Water Energy Nexus. This report will come up. Notice that the first 4 or 5 things that they have listed as their major issues of interest is thermal electric cooling, waste heat recovery and cooling system, processed water, alternatives for fresh water and energy production, and then advanced treatment desalination. So there will be, through the Department of Energy, opportunities in the next several years to look at approaches and research to try and reduce freshwater use in thermoelectric power and energy development. A couple of things that where I think that the major research is going to go. Dry cooling and hybrid cooling will be a big concern as we move forward. Ecological performance improvements, improved materials and cooling approaches, and then opportunities to change the electric grid such that we can integrate these low water use technologies like PV and wind into the mix such that we can utilize that better. Currently, dry cooling has huge impacts and penalties once you get above 100 degrees. So you can see in the southeast and in the southwest, dry cooling currently has some real issues So where technologies like hybrid cooling could be a big player. To quote a famous poet and philosopher, Bob Dylan, times are changing. This is my last slide. I just want to, we have huge opportunities in the United States right now. We're looking at a fleet of thermoelectric power plants that are generally 40 years old. We need to change those out. We can and we do have the opportunity to look at new approaches, new technologies, new cooling directives. Some of the policies that we're seeing from the EPA are focusing on driving us to technologies that increase water consumption. We need to make sure that we don't let those types of regulations drive us into unsustainable freshwater practices. We're seeing in the U.S. a big movement toward the use of degraded water for cooling. 70 plants now use wastewater for municipalities for cooling. That was about 35 plants 5 years ago. So we're seeing tremendous growth in that direction. And finally, I think we're seeing that the Electric Power Research Institute, National Science Foundation, and industry are really moving forward, understanding that this competition for fresh water is a big deal if we look at long-term sustainable energy. And what I have here is a picture of Plant Bowen, which is a water treatment research center with the Southern Company, the Georgia Power, which is an industry effort to really try and do large-scale testing of new technologies. So with that, I hope that I've provided you with some background on the connection between water and energy, especially thermoelectric power generation, some of the issues that we have currently, and some of the directions and approaches I think that we're going to see and opportunities in the next 2 decades to really help reduce the competition with other sectors for freshwater use by the electric power sector. Thank you very much. Thank you.
Our next speaker today is an exceptional forward planner. In fact, we heard he was going to attend 365 days ago. I'd like to introduce Mr. Ashish Aneja, who leads the Open Innovation Strategy at General Electric. So please give a very warm welcome to Ashish.
Thank you, Ronan, for the kind introduction. So a couple quick comments I wanted to make before I present what Ronan and the MIT Water Club asked me to do. One is, how about we settle on this whole water-energy nexus and call it the water-energy nexus, right? We're the Water Club here. I myself am invested into, the water business, working for the GE Water business. So, let's just call it the water-energy nexus. Second is, I think, I'd like to thank the MIT Water Club for doing a fantastic job in terms of pulling this forum together, bringing together industry, academics, investors. Fantastic job. I know this is the second time you're doing it, and I'll be looking forward to the third time as well. So great job done by the Water Club team. So what I'd like to do for the next 10 or so minutes is talk to you about some of the key trends that we see from a GE Water business standpoint in the industrial segments that we serve. So I won't touch upon things that we do in municipal or drinking water from that standpoint, but really on the industrial side of things, what are the key trends that we see? How do we see new needs emerging? How do we think about positioning ourselves to address those needs in terms of positioning ourselves with new technologies, entering new markets, new spaces, and so on? And then, industrial segments that we serve, that we touch upon, are very broad in nature. So I won't have time to go into detail around all of the things that we touch, but I thought I'd share, 3 or so examples about, and go a little bit more deeper into, what we're seeing and, how things are playing out at present time. So what are some of the key trends that we see? Unconventional oil and gas, right? It was touched upon very briefly yesterday as well. There were questions that came up last night for those who attended. It's really driving water and reuse demand, right? And when you think about unconventional gas, at least in the United States, the lower 48, we hear a lot about, fracking, right? And there's a lot of interest, a lot of momentum there. But outside of that, even if, as you look at, for for example, Canada, and what they've done with heavy oil recovery using in situ SAGD type of processes. Big impact that the industry has made, water folks have made in that part of the world as we've thought about recovering unconventional oil. And the other piece is around Australia, where coal seam gas, again, that's a market that's mandated to go to nearly zero liquid discharge. And again, water's played a big impact in Australia as we've thought about taking coal seam gas and recovering it. So I'll touch on that a little bit more as we go along. The second one is around refinery and processing, opportunity crudes. So opportunity crudes, as we think about going after more like tight oils and the heavy oils in Canada, for example, guess what? These crudes show up downstream in our refineries. And these are often considered as opportunity crudes in the sense that they are made available at significantly or somewhat discounted rates as compared to the crudes that refinery use otherwise. But when you try to process these opportunity crudes, you run into issues around desalter operations, into wastewater treatment plants with respect to the composition of these crudes that they come into the refineries and how these are treated and processed. So a little bit more on that as well. The third trend that we see is, which has been going on for a while, is around recovering resources from wastewater. So we heard a lot about water reuse, and both from an industrial standpoint, as well as even from an indirect portable water reuse standpoint, as we've seen, for example, Singapore lead the path with that regard in terms of taking wastewater, treating it, putting it into an aquifer or reservoir, and then drawing from that reservoir to take water to a drinking water plant, and then supplying that back into the drinking water system. So again, Singapore's done a fantastic job, I think, there, and then other places in the world are following. Places in Texas are looking to do it, and the last I heard, even in California, there's a couple places where that's being considered as a way to manage water. The other two pieces around resource recovery are, one is recovering energy. So as you think about the water that you send to a municipal wastewater treatment plant, there's more energy in the water itself in terms of a BTU value than what's needed to treat the water. So looking at new technologies around anaerobic digestion or even some of the more advanced, newer concepts around electrogenic bioreactors, we see a lot of interest in that segment as well. And then final, which I think is still in its infancy, is around recovering nutrients from wastewater, which is recovering things like nitrogen and phosphorus-based struvite type of fertilizer, still in its infancy, but again, we see a lot of interest there. I won't spend much time on food and beverage. I think Daniel touched on that a fair bit yesterday, both from a sustainability perspective, big data perspective, as he spoke about iCrop last night. But again, we see more and more that sustainability is a big thing in the food and beverage space. And what's really nice there is the KPIs or metrics that they use around measuring the amount of water that they use per gallon of, say, a beverage that's produced, or per gallon of a beer that's produced. And I think that's fantastic. We don't do that, for example, in unconventional resources, right? As we look at the water balance, we don't really have metrics in place looking at, if we're deep well injecting the water, how much of that water are we really losing from the environment and taking it out of the water cycle? So from that perspective, around sustainability, I think food and beverage industry does a great job. The next item is regulations continue to tighten. And that really speaks to a multitude of things, but where we see a lot of interest, a lot of change is around regulating heavy metals more and more, things like mercury. As you look at the Great Lakes Initiative, as you look at, for example, FGD processing, the selenium that comes out in FGD wastewater streams, those getting more and more stringently regulated is a trend that we continue to see. I touched on water reuse, acceptance of water reuse rising globally. Mike touched on that as well, both from an industrial and municipal standpoint, so won't go there. The other couple things I want to touch on is, one is this whole smart water, right? So smart water, depending on where you are, and if you're looking at ag versus industrial versus city infrastructure, means different things. But for us, what it really means is leveraging the Internet of Things, the industrial internet, to really look at how we can leverage big data and analytics to do things more smartly. How to manage our customers' assets like cooling towers, like boilers, in a more effective manner using concepts around big data and analytics. And then finally, I don't have it on this page, but it's this whole industry that's developing in China and growing very rapidly is coal to chemicals. And there, the tricky part there is that coal in China is abundantly available, but very often available in very arid regions. And then if you look at, what China's put on their 5-year plan is around, how to reduce water intensity overall as a country, as a nation. When you look at the coal to chemicals industry, they essentially want zero liquid discharge. And, we see a lot of interest and momentum from that perspective as well. So a few examples. This is a very simplified view of how you would treat produced water, be it in a coal seam gas operation, SAGD process, or unconventional frac type flowback and produced water. But a couple of things I wanted to point out here. As you look at, for example, those 3 segments, the needs change vary. One is regulations or mandates driving zero liquid discharge, such as the case in the SAGD space, where producers reuse, recycle about 90 to 95% of the water. And same is the case with the Australian industry for coal seam gas, where again, there's mandates to go to zero liquid discharge. What we don't see is that happening for the unconventional resources market in the United States, where the industry has really become more about managing the water via trucking, using disposal wells, and doing really minimal treatment so that they can reuse it with the right chemistry that makes the water amenable for reuse. So again, a lot of interesting things going on, opportunities to innovate as well. In fact, as you look at, for example, one of the things shown here is a thermal evaporator system. GE builds these systems, and we lead in the SAGD space, for example, with these systems. But we also see that these are very high CapEx and OpEx intensive systems. So can we redesign overall flow sheets so that we can do the pretreatment and de-oiling well enough, or do a good job doing the pretreatment and de-oiling of the produced water, that the water is good enough to send to an RO system, and hence it reduces the footprint of the evaporator that you have to put in place. So those are some of the key things that we think about as we look at this whole produced water treatment segment. Second example I'll share is, and this is an eye chart. I don't mean you to go into any detail. I don't expect you to do that. But it's again the issue about opportunity crudes, crude oils coming into refineries from tight oil, heavy oil type of systems or processes, and then figuring out as these oils come in, crude oils come into a refinery, which often have asphaltene, NAP acid type of issues. They often have high solids levels. They may have trampamines that are used in the process to scavenge H2S and so on. How do we really process these in the refinery? What is sort of the desalter technology that you need in order to be able to process these crudes? And then as you run crudes through a desalter, the desalter bottoms, the waters that go to a effluent treatment plant, a wastewater treatment plant, how can you really treat that water? Because very often, the kinds of things that you will see now in these wastewaters are different than what you've historically seen, in the sense that you'll see more recalcitrant organics, more tough to degrade organics, and hence, we see a shift in that direction as well. Refineries overall want to reuse more and more water, and especially in water-scarce regions, what we're seeing also is refineries going after point source reuse. For example, looking at unit operations in refineries where you have sour water stripper bottoms, and refineries looking to reuse that water so that they can reduce their freshwater withdrawals and also reduce the footprint on their downstream wastewater treatment plant operations. And finally, this is my last example for the day, is around this whole concept around the industrial internet, or what we call as the Internet of Things. And again, customers are asking us more and more, how can we really be more efficient in terms of maintaining our assets? And it's a huge productivity for them as well as for us as we think about servicing, again, assets like cooling towers, boilers, or even build on operate systems in terms of water treatment systems that we have with several customers. So here, the idea is, it's threefold, right? So you have all this data. can you structure it to give you descriptive reports, scorecards that really help you understand where your process is or where your unit operation is? The next level is, can you really be predictive? For example, if one of your processes you think is going to go out of control, there is going to be an upset, are you in a position to be able to predict that using historical data, using algorithms, and so on? And then the final layer is, to be prescriptive. That is, you can tell that, I want to do this. Maybe I need to increase my polymer loading to a cooling tower I'm treating. Maybe I need to do something so that my unit operation runs well. I'll stick to the cooling tower example. Can I minimize the corrosion of my heat exchanger tubes? Can I minimize biofilm and so on? And take those actions so that you can prescribe based on the data that you're able to pull in. So again, I think I'll wrap up for now. I hope I gave you a glimpse of some of the challenges that we see, opportunities that we see as a water business, and then looking forward to continue the discussion as part of the panel. Thank you.
We'll now move from one of the largest water treatment companies to one of the fastest growing companies. And I'd like to welcome the CEO and co-founder of DeSaliTech, Nadav Efrati. Thanks very much.
Thank you. So thank you, everyone, for being here. And I'm here as the entrepreneur. And I see kind of diverse audience, so I hope I won't bore too much the big corporate guys when I'm speaking to the entrepreneurs, but I guess all of us are to an extent. So I will tell you a little bit about my view of industrial water usage, and then a little bit about our company. You all know GE. You should know a little bit about us, but my purpose in being here, if you ask Ronen, and I did ask him, is to give some of my lessons about building a company in this sector and what are the special challenges. So much to say. I only have 40 minutes. I'll try to keep it brief. Water, generally speaking, we all know that the world will need more water. There are more people, more industry. We need to feed them all. You heard it all today. And for me, it's inevitable that over time there will be more desalination and will be more reuse. That's the future. The thing is that while there is a spread between water withdrawal and water consumption, you still see that in the developing countries, 70% of the water is being taken to the industry, while in the States, 60% of the withdrawal is to the industry, including the power. And in Belgium, for example, it's 80%. And the lesson is that as the world evolves, the industry is becoming a much more substantial water user. And this is clear. There's water in every single product we see around us, be it food and beverage, pharmaceutical, cosmetic, paper, textile, power. You name it, microelectronics, you name it, it has water. And most of that water need to be further purified. And for that reason, 70% of the factories in the States have reverse osmosis units. If you ask me, and you don't need to ask, I'm going to tell it anyhow because I'm here. We speak about water and energy nexus. Thank you, Ashish. I see this nexus, with even an additional layer. And this layer is that over time, water will become exactly like energy, a commodity that everyone knows that they need to pay for because it's being manufactured somewhere. So just like anyone knows that they need to save energy, the industry knows it, the households knows it, they will all know that they need to save water simply because they are going to pay for it. And that's the inevitable future. So I think we are kind of lucky as an industry that we have a crystal ball. We know exactly where the industry is going. We don't know how quickly. But that's inevitable. That's the direction, and I'll try to prove in a moment that I'm not the only one thinking so. But think that you had a crystal ball to tell you where the stock markets are going to. That's kind of cool, I guess. And we do have it here. So, today in the industry in the States, 70% of the factories have reverse osmosis systems, and I would bet that 95% of them work at water efficiency of 75%. Namely, for every 3 gallons that they purify, they need to buy an excessive gallon of water and then pay for the disposal of it. It doesn't make any sense, and still they all do it today, 2015 in a moment. So that thing must change, and our job as Desilytech is to change it. I'll keep my pitch very short, I promised, but what we're doing is reverse osmosis systems, as you see in the bottom of the slide. And our reverse osmosis system are smarter, we hope, and they enable us to operate at typical water efficiencies in the mid-90s, which means that we reduce the volume of water we waste and dispose of by about 75%. And in the process, we're saving energy. We use standard membranes in a way which makes them more reliable and immune to scaling and fouling and all those effects we don't like. And maybe the last point is that those systems are, I think, smarter in the sense that we don't design different systems for different applications. It's always the same iPhone. You know, I'm comparing here a calculator which has a single purpose to an iPad with which you can do everything. And we kind of bring this notion to desalination. Every system can really do it all, from industrial wastewater treatment to ultra-pure water in a power plant without having to change anything in the hardware. It's all in the way we control it. So it does bring innovation to this industry. And the last slide I wanted to show about the industry is that chart from Global Water Intelligence published this September, showing some of the hyping technologies through the disillusionment, and then the companies that are getting accepted by the market. And if you look at the right side here, do you see it? So the first in line is Nano H2O, have just been acquired by LG. And the next in line is us. And after us is Oasis. So you kind of have here the leading folks from two of the most advanced water tech companies in the world right now. This is great. This is also saying something about the state of our industry. We need a lot more. I think that the interesting thing to see here is that most of those technologies are all we are high recovery water treatment, and most of the technologies below us are brine concentration technologies. And that means that most of the innovation in our industry nowadays is actually focused, according to Global Water Intelligence, on improving water efficiency, which is the subject I touched a moment ago. So it's an honor, it's also a responsibility, and as part of this responsibility, I would try to share a few of my lessons on building a company. That slide is not really interesting, it's just a background. And the thing I wanted to discuss is how to build a water company, and I really only have a couple of minutes, so I'll do it quickly. The important things to do are like in any other industry. It's a matter of having a very good strategic plan and understanding that your first pilots are not going to change anything. It's all a long process of marketing and commercializing a technology that will make it work. And it all starts from understanding your customers and speaking with them, and customers, partners, competition, what are their triggers, how does it work, how would they pay, and so on. How do you construct your partnership? There are so many things to touch. Unfortunately, I don't have the time. So with the time I have, I would try to speak for a moment about being an entrepreneur in the water industry, which is probably harder in some respects. And I think that this is harder, first of all, because water didn't have value, and it's so hard to innovate where you save something that doesn't have value. This thing is changing, and this is great news for every innovator in this industry, I think. The other reason is that this industry is exceedingly conservative. Big corporate like to buy from big corporate, and this is something that is not going to change. And all of us entrepreneurs need to find the ways to engage those big corporate. And again, no time to speak more about that today. However, I think there are special attributes to our industry, and we should all work to fix them. And I think we are kind of in a vicious cycle, frankly, where there are not enough success stories, there is not enough investors' money coming in, and there are not enough experienced second-time entrepreneurs that are promoting water companies. And if you look at the top of the list in my previous slide, you'll see that Nano H2O, Desilytech, and Oasis are all pretty good in marketing. Maybe there's a reason why we are high at that curve. We do sell a viable product, but there's a lot more to building a company than just having the best product, because unless people will know about your product, they will never buy it, and you will never grow a decent company with that great product of yours. So how do we solve it? How do we build successful startups in our industry? First of all, we need to get back to the basics of building company, which is, again, very good strategic execution plan, not just to show investors how great you're going to be, but really to build your company, to have a compass, and build your company with that. And understand that it will take much more time and money and marketing and all those things which I've mentioned. So that's the first thing. The second thing is that we know, again, that the industry is evolving in the right direction, and there is place for innovation. And I've shown my idea of that direction, high recovery. Michael showed his idea about cooling towers and so on. And there are inevitable changes taking place. And use those waves, ride them. There is a place for them. And I think that the last piece of the puzzle is kind of what we're doing here today, speaking about this industry and what the New England Water Innovation Network does. I think that we as water industry members have this responsibility to promote innovation, even if it's coming from GE, God forbids. I think that really the industry, everyone knows the importance of water, but still very hard to get investment. And we are lucky. We've just raised $11 million 2 weeks ago with great oversubscription, but I know how hard it is. And we as an industry have this responsibility to promote the news about not only the problems in water, not only the need for water in Africa and in India, but the need to improve water efficiency here in the States. This will happen, and please help us get the industry there. Thank you. Thank you, Ronan.
Appreciate it. Sometimes an opportunity emerges that really demands a new technology that doesn't look like any technology before. And I'm really happy to welcome here today Lisa Marchuka, who is the Vice President of Strategic Initiatives and Marketing at Oasis. Please welcome her very warmly.
Thank you.
Thanks, Lisa.
So I have the coveted position of being the last speaker in the last session on the last day. So thank you all for sticking around, and I'm sure we'll have an exciting panel after this. So interesting, my career has been 15 years, or actually 12 years, in a rather big water company with lots of different technologies doing lots of different markets. In the past 5 years at a small water company. So starting at, I was employee number 7, and moving us now to about 60 employees. So I was asked to talk to you a bit about today about the emergence of produced water, specifically unconventional. So that will be my talk today. And if you could help me figure out, I just keep going. Okay, nope, that's still Desalatech. Okay, here we go. So when we talk about unconventional oil and gas, the first question people always say is, what makes it unconventional? Why is it conventional? So conventional really just means that it's conventional drilling. So it's vertical wells that are being drilled. So a lot of the oil that we have was basically vertical drilling. What we're seeing now is with technology changes, with the inception of horizontal drilling, most of what we call today unconventional is actually becoming the convention. So there are about, in the United States, just to give you some rough numbers, in about 2009, there were about 400 rigs that could do horizontal drilling. Right now, there's about 1,300. So a huge growth in the number of rigs from a horizontal. Horizontal drilling is a lot more expensive than vertical. Why? You can tell there's a lot more piping that's involved. And of course, the big thing for us and why we're all here today is there's more water. So the difference is instead of punching a hole in the ground and going into a big oil reserve, you're essentially fracturing rock. And in order to fracture rock, you need to have water and proppants and chemicals that you can cut across a shale. But there's typically much more water involved. The interesting thing, though, is that's only one piece of the puzzle. There's a lot more water that goes in, but everyone thinks that that means that there's more water to come out, which isn't necessarily the case. So what you'll see here is this is a rough snapshot of different areas of the world, and for every barrel of oil or gas produced, how much water is produced. So you'll see it's not just the unconventionals that are putting out a lot of water. The average number of barrels of water for every 1 barrel of oil in the United States is about 7.5 or 8. Oman is about an 8-to-1 ratio itself. The Permian Basin, which is mostly shale, is about a 3-to-1 ratio. But then you go to the Mississippian line, it's about a 12-to-1. So we're talking about huge volumes of water. The other interesting thing is of those 1,300 rigs that are currently in the horizontal drilling, it used to take about 4 to 5 weeks to move a rig. Now it's every 1 or 2 weeks. So you can imagine that we went from there being a small number of wells being drilled to 50, 60,000 new wells being drilled in a given basin every year. So that's a lot of water, and that's the conversation that's happening. So what is this water doing? So it's interesting, everyone used to think about water and produced water and unconventionals as frac flowback. So 5 years ago, everybody cared about frac flowback and the water that was coming out. It was really salty, and all these companies said, I'm gonna make a technology that does desalination, I'm gonna tackle frac flowback. Well, that's great, but the problem is that it's a really young field. So in a young field, you take the frac flowback, you blend it with other water, bada bing, bada boom, you don't need to do any desalination. The big problem is what happens over 30 years. So as that well still produces oil and gas, you still have water. So the big problem is what happens when you stop fracturing. And when you stop fracturing, you don't need any more water. What are you gonna do with all this produced water? Now, one would think that, well, that would be a perfect place for you to do treatment. So in the United States, like I said, there was a lot of people that decided that they were going to do treatment. They see numbers like it's $25 to treat a barrel of water in the Marcellus Shale. And it's $10 to treat a barrel of water in the Bakken. But what happens is that a lot of people didn't think about logistics. And so logistics come into play quite a bit in the oil and gas industry. So being able to put water in a truck and drive it to Ohio is simpler than investing the capital and actually treating the water for $4 or $5. That, however, is starting to change. As regulations come into place for seismic and disposal wells, we're starting to see a shift away from that. But by and large, in the United States, we're not seeing that big of a push to do a lot of the big treatment that we thought there was going to be 5 years ago. 5 years ago, the discussion was, what are we going to do with all this salt? We're going to have more salt than we know what to do with. We're going to put Morton's out of business. There's going to be so much salt in the world. What are we going to do? And really, the discussion has moved away from that and moved to how do we manage the water in different ways. What's interesting, though, as I will say, is that gas prices have dropped below $3. So one would think if gas prices are down, people want to invest less. I will say that in the past 3 weeks, as a company that has a forward osmosis technology that can desalinate these difficult waters at a very low cost, we have seen probably more proposals and RFIs come in the past month than we have over the past 6 months. So it's very interesting is that now that the costs or the price is going down, your cost margins mean more. So we're actually seeing more people wanting to do treatment when before they had not. But the United States is not really where much of the focus is in terms of treatment for produced water. So if you took Mike's map that had precipitation and water scarcity and overlaid it on this map, it would be very, very telling. So he showed that in the southwestern United States, of course, there's drought. Australia, of course, there's drought. Inland China, same thing. And if you took that and you looked at where all these wonderful shales are, you would see, uh-oh, no water, a lot of shale. How do I extract it? So that's a lot of what's happening. So areas like Australia, or China, in fact, but Australia is one particular one where they have water scarcity, but also they have a really stringent regulatory environment. So much so that the water's coming out of the ground when you do coal seam gas, it's not actually that salty. It's stuff that an RO could treat. And that's what they did. They put it through an RO, they put it in a big brine pond, and they let it sit there. The problem is now is these brine ponds are becoming so massive that the Queensland government has said they're banning these things. So now what do you do with all this water? So now they're looking to brine concentrate this water and to sort of take it to zero liquid discharge. The interesting thing for us is that they have one installed thermal evaporator in place, and most of the big companies, there's really only 4, are now looking at trying to concentrate this water with technologies that are not thermal. So interesting that the market has evolved that, when we think about, and Nadav was talking about being an entrepreneur in a conservative market, it's very interesting in this particular market, the pace of innovation and the emergence is really coming at the same time as the technology. So the two are going hand in hand, which allows new technology providers to really develop a solution for a market that has yet to develop. China is another interesting one that I'll just touch on. The China market, most of the shale is actually inland, and their issue is that they don't have water to bring inland, and so desalination is another option for them to bring water in. So produce water, this is my favorite slide as a marketer. So when an engineering team says, great, produce water, let me design a system. Tell me what the water is. And I say, sure, absolutely. It's really easy. It's just like seawater. It has a really small range of salinity and a really small range of hardness, and it might have algae, it might not. Not the case. Location to location, well to well, the salinity and the hardness of these waters is all over the map. So there is no one size fits all. There is no one treatment train that fits all. More often than not, you do not require desalination, but when you do, there are very specific cases that you have to use very high treatment. But I will say that what's interesting about it is it's not just about the water quality. So if you look at it from terms of salinity versus hardness, so monovalence versus divalence, a lot of what the oil and gas producers are concerned with is scaling the casings. So you really scale the casings with the divalence, not the monovalence. The problem is it's really hard to remove. Well, you can remove the divalence with softening, but nobody wants to deal with the logistics. So then it's difficult to remove dissolved materials unless you can remove both at the same time. So that's why desalination had become the big argument. But if you look at why they're doing it, it's all about cost, right? No one's going to do something for the good of humanity, although they should. But it really has to do with whether or not they have enough water to continue fracturing and how much it costs to dispose. You are relentless with that. Cost to dispose. But what's most interesting is, like I was saying before, that doesn't always work either. Really, what's really driving whether or not you're going to do something is typically whether or not you have to do surface discharge. And surface discharge is really what's happening in areas where you hear about ZLD regulations, zero liquid discharge, where you have no more injection wells. There's now requirements for seismic. Ironically, that the people that have to get the permit the people that get the permit to do the drilling are also the ones that provide the information on what the seismic capacity to get the disposal well is, so a little counterintuitive there. But there's this growing need that there's going to be surface discharge. And as that happens, you'll start to see these cost drivers really take over. But the most interesting thing to think of here is that there is no one technology. There are lots of different things, from walnut filters to wet air oxidation to RO to evaporators to Oasis's forward osmosis membrane brine concentrator that can take the place here. So I'll leave you with the parting thought that it's a global problem. It's a massive problem. Cost of gas and how much you pay at the pump is actually helping us. We thought it would hurt us, but gas prices going down for you means that cost is a bigger issue to these producers. So thank you, America, for using more gas. And then it's also really regulatory driven. So I show you this map of Australia. About 80% of the reserves are in the area of Queensland, and they have banned the ability for them to put water in these brine ponds, which is a beautiful thing for a technology company to come after a market where they don't like thermal technology, they don't like logistics, and they have big problems to solve. So with that, I will leave you, and I assume we're going to start our panel now. Okay.
Thanks very much, Lisa. Thank you. You can have a seat over there. I'll now just invite the panelists to join us up here on the stage, and we'll begin a discussion. Let's begin by talking about oil prices and how they have affected water companies and the water industry. Just about 6 months ago, the price of oil, of Brent crude, was about above $100, and today it's gone down to about $60. And so maybe, Mike, could you start off and tell us, from the power generation business, who are the people who are going to be quaking in their boots, and who are the people who are going to be jumping for joy when they see that price go down as it has?
You know, in the United States, there's not that many oil-fired power plants anymore. So I'm not so sure that you're going to see a big issue with oil. But along with the oil going down, the natural gas prices went down also. So we're seeing a big movement toward natural gas power plants. And because of the lower water use intensity of natural gas, we're seeing a lot of interest in utilizing natural gas power plants. And if we continue to do that, there are going to be some regions of the country that actually benefit by these lower costs because of the less water consumption with those types of natural gas-fired power plants.
Right, yeah, this is interesting because I was expecting it to be a drawback. In fact, I looked up online, I was looking at Halliburton and looking at the price of Baker Hughes stock, and it's amazing how similarly they track the price of oil. The drop is very similar to that drop I told you for crude oil. And so maybe, Lisa, could you tell us on the ground, what do you see when the oil price changes?
So it's interesting. Actually, just 3 days ago, there was a oil and gas conference in Keystone, and one of the producers from BP came and said that about a third of the operating companies, the operating oil companies, are in the red. So it's interesting because it depends if you're talking IOC or the independents. So when we're looking at the independents, the small independents.
Sorry, Lisa, maybe just tell us about IOC as well.
So the larger, the international companies, so the Shells, the Chevrons, the BPs, the ConocoPhillips, the bigger companies that are in true oil versus the smaller independents that are in natural gas, so the Pioneers or Cimarex or some of the smaller producers. They have very different cost models, and that's a lot of the reason why you've seen some of the bigger companies move out of shale in the United States and move out of other areas. So I think for the bigger companies, it's certainly a negative. It's negative for all. But what we're seeing, actually, is that the independents are taking it as a time to think through how to reduce their cost. And if you think about water and water usage, especially in gas, it's about between 10 and 25% of the total cost of operation. So if you can cut that cost in half, then all of a sudden you start to see profit margins go up.
And so do you think this is a short-term phenomenon and maybe there's a long-term disadvantage but a short-term advantage? Is that fair?
So it's interesting. So I would say that in the United States, it's still yet to be determined if there's going to be anything more than discussion and planning. It's such a volatile market that it's hard to really get a crystal ball to really understand what's happening. Again, the big driver in all of these areas is cost and regulation. So if you can see if there's technologies that they don't have to invest a lot of capital up front that can reduce their total cost of operations, I think that's a win.
Right, great. And Ashish, you're involved in much more than just unconventionals, and I know, of course, Oasis are as well. Are there particular parts of the oil and gas industry that are being a lot harder hit? And what are those parts? What about the steam-assisted gravity drainage in
over
Canada?
there, in the SAGD space, I think it's very hard for the SAGD producers to compete with 59, which was the price for crude oil yesterday, right? 59 and change. I didn't check today if it dropped below that, but that's how low it went yesterday. And what we're seeing is some of the projects are likely going to get pushed out a little bit, and people are not, or producers are not going to add capacity as per their original plans dictated. So that's going to probably shift things back a little bit or shift things into the future a little bit. And that is going to impact, the water business in that part of the world.
Right.
From an unconventional standpoint, I think it's, since that industry is in some ways more fragmented, it's a little hard to say, what's really going to happen, or we haven't really seen an impact today, but I think it'd be fair to forecast that at least from a water treatment standpoint, when we talk about minimal treatment to enable water reuse, right? So where the service companies can take the flowback and produce water, and they can do minimal treatment, and then the producer can reuse that water with ionic strength polymers, tolerant polymers and whatnot, and reuse it. That's a very fragmented industry. It's a lot of mom and pops who are really doing that. And I think what we will see in the future is some of that consolidation is going to occur, where some of these smaller shops may be forced to fold operations because they may not be able to compete.
And you think falling oil prices will possibly accelerate that?
Yeah, I think that may have a role in that.
Sure,
yeah.
Sure. And just continuing onto unconventionals, Lisa, you mentioned an interesting point about how we saw things so differently 5 years ago. I mean, to give the audience a context, in the last 5 years, oil production from shales has gone up by 8-fold, gas production by 4-fold. And so when you see, as Lisa showed, there's more than 1 barrel of water per barrel of oil, you just think this is something huge. So what size is the market now, would you say?
So I think that the United States has 80 billion barrels of water that's produced. But that doesn't mean that all water is treated. That's the water that comes out of the ground. A lot of that is cut and reused. There's companies that are coming out with technologies to use chemicals so that they bind the divalent so you don't have to worry about it from a casing standpoint. The real question is how much of that is being treated? And really the question is how much of that water is in a mature field where there's no additional fracking, where you need to do surface discharge. And that is a much smaller subsegment of that number.
Right, I see. I don't know, Ashish, would you be able to put a dollar figure on the market, you think, for high salinity water treatment in the US even?
It's small. For high salinity water treatment,
I mean, small for GE is pretty big.
Yeah, so I would say if you look at the overall global, let me start there, overall global produced water market today, that's about like $40 billion on an annual basis. Now, if you look at, with respect to the unconventionals, a big chunk of that, and I know that even within that 40 billion, there's coal seam gas and SAGD and other unconventionals. But if you look at the UCR, unconventional resource market, it's a lot of it is around, trucking the water, water management, disposal wells, and so on. And then there's a chunk of it. So, I don't have the exact dollar numbers, but, I'll try to estimate some. But if you look at unconventional water market in the US, I would say 60 to 70% is around water management, be it trucking and saltwater disposal wells. I would say 20 to 25% from a revenue perspective is really around doing minimal pretreatment. So using standard technologies like lamella clarifiers, flotation cells, and whatnot, so that the producers can reuse that water. And it's a small sliver.
Right.
I would guess less than $50 million, less than $25 million.
Yeah. So
Maybe even less than $10 million, where there's opportunity to really do the desalination. So it's really very small, in very small pockets, a project here, a project there, where there's a true need for desalinating the water today.
And Lisa, I know you've done some work outside of the US, so I mean, how much bigger is outside of the US versus inside of the US?
Much. In fact, most of our operations are not in the United States for that reason. So I would say that, for just high recovery desalination, so, high recovery RO, evaporation, crystallizer, ZLD, the market in the United States, the lower 48, is somewhere between 10 and 15 million. If you look at what it is for SAGD, that's about a $200 to $400 million market by comparison, so much larger. If you look at Australia, that's more of like $150 and $200 million market for the same thing. So the opportunities for high recovery and evaporative technologies are certainly in other areas right now.
Right, great, Lisa. Now, I can't move on without asking this question, and Mike, you might lead us on this one. What do you think are the biggest misperceptions around water use in the unconventional oil and gas industry?
Probably, trying to frack a well in unconventional takes about 3 to 6 million gallons of water. But a lot of that water is reused and stuff. So it sounds like a big number, but it's surprising if you compare those kinds of numbers to the amount of water that we withdraw on a daily basis for electric power generation, which is 250 billion gallons of water a day. It's not a lot of water. It's probably a manageable amount of water. It's large locally, but in the scheme of things, in a large region, it's not as big as people might think. Right. Still, though, if you're in a county that's doing a lot of fracking and you don't have a lot of fresh water, it can be a sizable percentage.
Right.
So you have to, the water issues are local, and you have to look at it. But I think the biggest issue that people kind of claim that fracking is a giant consumer of water, it's not as big as, from a global perspective, as people would think.
Right, great, great. Let's talk a bit about one of the most popular buzzwords this decade, which is innovation. And I'll begin with you, Nadav. I think one of the questions people often have is whether it's the technology that's behind the success or whether it's the marketing or the entrepreneurship. And the question I like to ask is, well, let's say DeSaliTech happened, but it happened 15 years before it actually did. Do you think it still would have had the same success, and why?
So I've started this company with my father, who's a professor of physical chemistry, who has been working on it for over 15 years. So it kind of answers your question. And to be frank, when DeSaliTech started, what we were trying to achieve is reduce the energy consumption for seawater desalination. That's the truth. And we learned that, replacing existing reverse osmosis with big tanks, with submerged membranes and big pistons can be a lot more energetically efficient. And we invented that in the day before isobaric energy recovery devices. So that whole notion of using hydrostatic pressure was completely new to the world. And since then, isobaric energy recovery devices came to rule the seawater desalination energy recovery market, and we were there a lot before them. So to answer your question, yes, developing the right technologies is, of course, the foundations, but having the right foundations is not going to, build the entire building on top of it. You're not going to be able to rent or capitalize on your foundations. So, and I think that too many of the entrepreneurs in our sector are the technical guys, and not many of them understand the value of having a clear vision on the commercialization side, and the combination is what makes the company. I wouldn't have done much without a decent technology to begin with. The technology didn't go far before I was there, and it's the combination, I guess, in every kind of potential success. And we're still potential. We still have a long way to go, despite how Global Water Intelligence marked us. So,
right.
Yep.
Yeah, and I like the point you made that there aren't, maybe just in the desal area at least, any massive successes, and that makes it very difficult because venture capitalists don't see that big success and that big payoff. In fact, one of the points in the graph was Nano H2O, and though they were acquired, we didn't see any dollar figure. And so are DeSaliTech going to put out the dollar figure? I mean, that's maybe an aside, but I think it's an important one.
For Nano, it was between 200 to 250.
Oh, okay. Well, we've narrowed it down.
Yeah.
Great. And in fact, earlier this week, we had Peter Thiel, who's a well-known venture capitalist. He, of course, founded PayPal and was the first investor in Facebook. And his main argument earlier this week was that startups need to achieve a state of monopoly because that's how they can have margins big enough in order to pay back their investors, for one, and be long-term profitable. But I think when we look at the water industry, what we see is a lot of competitively bidded contracts. And I think you probably have all experienced a mix of different types of contracts. And so probably to Lisa and then to Ashish, I mean, how can you do a startup if everything is competitively bidded?
Yeah, it's a good question. And much like the history of DeSaliTech, Oasis actually started in seawater desalination. And we decided that going into a different route, going into industrial and going into something that was really a pain point for customers. So looking at brine concentration, people don't like the idea of thermal and a lot of technology, and having a technology that could kind of solve that problem helped to make adoption easier. But I would say that by and large, the idea of having a competitive bid is certainly one on the municipal market. The industrial market is a little more open, not a lot, but little more open to new innovation and doesn't need to see, an apples to apples comparison. What they're looking at is cost, reliability, total, OpEx. Whereas on the municipal side, you typically have the engineering consultants that are the ones that are comparing, one membrane to the next membrane, and so on and so forth. So to overcome a lot of the challenges, which is what both Oasis and DeSaliTech have done, have moved away from the municipal market, and for that reason gone into industrial, where you can get some quick hits and some quick projects.
Right, yeah, great. And Nadav, I think you might have a story as well on how you avoid those competitive situations in the case of DeSaliTech.
Yeah, so when we've started Desalitec, we were looking for the right partners. By the way, it was long, naive days when we thought that all we need to do is prove to the world that our technology works and the world will come to our doorstep because that's a great technology. And at the time, we were speaking with GE, as well as all their competitors. And it never really happened. We were speaking with them, but the spread between speaking with a corporate and having it invest, not to mention adopt the technology, is unbridgeable for most startups. And so we decided to take our faith in our own hands and build a company and grow it to a place where, we won't need them. Then it will work. And today, we work only with partners. We're not going to see end customers at all. We work well with Veolia. We work well with other big partners. And they take our units and integrate them as part of bigger projects. So we certainly understand the value of partnerships and certainly understand the value of not competing with your partners. We are there. Just last week, I participated in the panel about partnership for water and energy companies, and sat by me Shell and Schneider Electric, and we all agreed that strategic partnership for young stage startups cannot really work. Don't bank on it. It will be like a once in a lifetime luck when it does. However, I think that there are different stories, and to the extent Lisa would like to share, I think that some of the strategic partners of Oasis, for example, are opening doors that Oasis couldn't have opened alone. So my take on that is that if you can avoid the strategic partners and build your company to a mature enough state, you might be doing a better service to this company. However, if you cannot do it and you have an interesting opportunities to give your technology with a very, very big exclusivity to a potential partner, and assuming you make sure that this partner have enough skin in the game to actually make it work and not just take your technology and sit on it, it might not be a bad bet at all. So it didn't work in our humble experience, but there are other cases. So.
Yeah, Lisa, and feel free to tell us your own experiences there. Yeah.
So I came from a big water company, and being in a big water company, part of my job was to figure out what little companies to buy. And going through that process a few times, it's difficult, because when you're a big company, you have your own sort of stage gate, you bring things through a process. Bringing in a new technology is often difficult to get the right people in going. So our approach to strategic partnerships was a bit different. Our approach was not to work with people in the water industry, but in fact to work with companies that are in the industries that we wanted to work in. So we have two partnerships that have really brought us into market. One is with an oil and gas service provider, and they also build equipment. So that helped us get into the oil and gas market on a global scale, places like the Middle East, where Oasis as a small company couldn't go alone. And then on the other side, really trying to get into China. And the way that we got into China, and the only way we would go into China, is to have a strategic partner that was also an investor, so they had skin in the game. And by doing that, what we were able to do is have a very open relationship. And these folks are bidding on projects and bringing our technology in. They have the relationships, they have the local procurement, they have the local design contracts, and they bring us in. And because of that, we've been quite successful bidding against the big companies on thermal evaporators and successfully winning them. So bringing, a young technology to market for a major, like the third largest company in the world is now using Oasis technology. So that's how we were able to do it, is thinking outside the box on what a strategic really is.
Yeah, so just to put that to you then, Ashish, I suppose in Nadav's case, there's been a realization that going solo has worked well. In Lisa's case, it hasn't been a competitive partner, it's more been a strategic partner. So what about partnerships with competitive partners? And
I don't think there is one right approach, right? Obviously, different companies go through different development cycles, they try different things, and some things work and some things don't, right? But I think coming back to the original question you posed, and in my current role, I look at a lot of external technologies and figure out how to bring them into the realm of GE via licensing, joint technology developments, small acquisitions, and so on. The one thing I look for really is, first of all, it's got to be aligned with the GE vision and what we want to do for the next few years and all of that, right? But we really look for a strong value proposition, right? So the new technology that we're looking at has got to be significantly better than what we have in our portfolio via what we do or access to other third-party technologies that we may have. And when I say it's got to be significantly better, it could be 5% better on a percentage basis, but that percentage basis has got to translate into significant dollars, right? That's really a strong value proposition. So for example, if there is a new technology that reduces energy consumption for seawater desalination by 5 to 7%, and you take it to large-scale desalination plants, considering all the volume of water that goes through it, that becomes very attractive, right? Even though it's a 5% improvement. On the other hand, if you're going to be treating only 100 gallons per minute of water, you're looking for 20, 30, 40% improvements so that you can monetize on that. So I think that's really very key is, what is the dollar value proposition that, we can get via, the use of new technologies.
Right, great. Now, this is an industry panel, and of course, earlier we've touched on a lot of matters of policy. So I did want to touch very briefly on questions of politics and just get the panel's experience of where there have been challenges and frustrations. And I might just start with you, Mike, in relation again to the power generation industry.
Well, I think one of the biggest issues that I run into is that most regulatory agencies regulate a part of a natural resource. So and I'll use California as an example. I mean, the Coastal Commission is not tied in with what the Energy Commission and what the Water Department in the state of California. They banned seawater cooling. So what did that do? That forced the power plants off the coast that were using non-fresh water for cooling, moved them inland to use fresh water to cool that they didn't have. So that's where you have regulations by one organization that are totally against what would be good for another group. So I don't think that we see in the regulatory community this systems level look at what I'll call natural resources sustainability. You make changes in greenhouse gas emissions issues, air emission, that don't look at land issues, water issues, ecological issues. So I think that that's the biggest problem is trying to raise the level of the regulatory community to the point where they look at the systems level impacts from a natural resources perspective, if you will.
Great. Yeah, and Nadav, I was curious whether you had any experiences. Of course, you have operations in Israel and, of course, in Boston as well. Perhaps there are some experiences you could share.
Yeah, so in terms of regulatory affairs, Israel is interesting. But recently, we've done quite a lot of work in California, and indeed, California seemed to be one of the biggest challenges imaginable. And we work in California both with farms and power producers and general manufacturers, and it's so hard time after time. It's like, well, enough said about California. But the driver for our business is totally non-regulatory. It's simply a combination of saving money through saving water. And in food and beverage industry and so on, the awareness of sustainability, which is very strong in that sector. So sometimes even when the dollar numbers are not that impressive because they do get their water for free, they understand that they are competing for this water with someone. So these are our drivers. However, speaking about politics for a moment, we came to Massachusetts, from Israel to Massachusetts because of the governor, Deval Patrick, who has invested a lot of effort, as a minimum, in promoting Massachusetts Clean Energy Center and later the entire notion of the water cluster, the New England Water Innovation Network, and so on. And we joined him for trips in Japan, Mexico, and Israel, and not just us. I really think that Massachusetts is starting to build itself as a global water innovation hub, and it is not happening by itself. I think that we are here because he kind of brought us. And I think that this is starting to build here something which is bigger and nicer. And in this respect, politicians had very nice influence on our life as a company, and I hope on the life of our group here as mostly local water industry leaders.
Great. I'm now going to give the opportunity to our audience to pose a few questions to our panelists. We do have a microphone on either side of the auditorium. I'd ask you to keep your questions within 144 characters. And I'd also ask to finish with a question mark or hashtag MIT Water Summit.
Thank you. A very interesting panel. I was just wondering if you
I'm
could
sorry,
speak.
yeah, you might like to give your name.
Oh, sure.
and
I'm
institution,
Sharmila
please.
Murthy. I am a law professor at Suffolk Law and a visiting scholar at Harvard. So I think about these issues from the legal regulatory standpoint. And I was just curious if you could speak a little bit more in the fracking and unconventional oil and gas industry. In particular in the U.S., there's been, at least in the popular media, a sense that regulations have not kept pace with the changing technology, and in particular what's happening at the state level versus the federal level. And I'm wondering if you could speak to that, and from your perspective, do you see that as a potential driver for your business?
Mike, would you like to start that? And then, I don't know, Lisa?
I actually have two answers to that, which is, kind of a dichotomy, I guess. I think what we saw originally in some states, and I'll use their example, they talked about invasive species, and this was in Pennsylvania. Their definition of an invasive species was somebody with a truck that had a Texas or an Oklahoma license plate. So, so this is 5 years ago when their laws were such that they hadn't seen oil and gas. They were allowing people to pump stuff off into streams, and all of a sudden, within 3 or 4 years, they've gotten a lot smarter. So I think a lot of states quickly catch up. But I am seeing, on the other hand, the issue around in regions that are water scarce, Permian Basin as an example, that there is a difficult time to get some of the regulatory agencies to say, oh yeah, there's brackish groundwater, why don't you use it for fracking? It's easier to go buy fresh water, and the people have the water right, and we're seeing in some cases then a lack of regulations to try to protect fresh water. So we're seeing things getting better in some states and things still changing in others. And I think the regulatory guys oftentimes are 2 or 3 years behind. But they do get smart. We got to try to get them smarter quicker than what we've done. So does that answer your question, or from my standpoint? There are others that are going to answer.
Yeah, and maybe Lisa, you've seen, of course, a more worldwide view. Are there times when you're elsewhere in the world and you say, oh, regulations are really far behind here?
So I'll come back to the United States, but from if you look at other countries, the federal government is what's driving change. In the United States specifically, and even in the Permian Basin. So what's happening is it's very much mandated across the states. The Marcellus situation was really cut across 3 different agencies. So if you went to the DEP in Pennsylvania, somebody was in charge of siting the well, somebody else was in charge of dealing with the water, and somebody else was in charge with the guys trucking it somewhere else. So that has changed. So they have moved so that there is one agency that can handle all of those incoming requests. They do have legislation that says that if you're going to discharge produced water, then it has to meet certain criteria, specifically being below 500 parts per million of dissolved solids, and it's broken down what can be in that. However, and there's also actually a way to get plants permitted so that you can both have surface discharge and reuse it. But however, the modus operandi right now is that there is not a lot of surface discharge, that big companies like Chesapeake are trying to reuse as much water as possible. And some of the other players like the Shells and such, they're trying to figure out what they're going to do with it. So it's really being driven by a cost metric, less by a regulation. In Texas, on the other hand, so it's really the Texas Railroad Commission that has primacy over what's happening. And the woman that runs the head of that, I sat with at a conference not too long ago, and she was essentially saying that the issue is not that there is not enough water to use for fracturing. There actually is enough water. When you go get a permit to drill a well, you can also get a permit for a disposal well, which was what I was referring to earlier about the seismic issue. So there are regulations. In Texas, it's quite different. It's not 500, it's 3,000 parts per million. So there are regulations. What's interesting, though, is that from a federal level, I think the one thing that was interesting that's happening is the impact of how seismic is impacting how many disposal wells there can be. So if anyone had heard, I'm sure you've all read on the New York Times, however, that Ohio was having earthquakes. Well, why was Ohio having earthquakes? They're saying it's because of the injection wells, because you're under just tremendous pressure trying to force that water into the ground. So at a high level, the EPA basically was saying, if there's any more seismic activity, we're shutting you down. So you better figure out if there's any issues before we give you the disposal wall. So I see that happening. I don't see a lot in terms of regulation specifically on reuse. There are some legislation that right now, if you take water out of a well, then you can only use it in that area. But there is legislation now in Texas that says that if you're a producer and you're a producer, then you can treat his water and reuse it, which has opened up many more opportunities to have sort of centralized treatment facilities. In fact, there's one company that we're working with that they want to be a net zero user of water, but that's more of their kind of triple line reporting, if you will. They're doing it less from a regulatory standpoint, but that regulation has allowed them to do it. They can actually take other producers' water and treat it to a level where they can surface discharge it, and they can say from a green perspective that they're net zero. Is that helpful?
Ashish, did you have one or two comments?
Yeah, I just want to add to that. I agree with the comments that Lisa made around surface discharge and the seismic activity and all the issues around earthquakes and drilling saltwater disposal wells. The one thing I think overall is missing that would direct regulations is we don't really have a metric. We don't really have a metric to understand what is this whole unconventional fracking industry doing to the water cycle? How much of the water are we really putting out of inventory, for example, right? So we use water, we put it downhole, or we use water to frack it. Then the produced water comes out, some of it gets permanently put away from the inventory in a saltwater disposal well. Some of it you may reuse. In very rare cases, you may surface discharge it. So what is sort of that, if this is the level of your ground level, right? How much water are you putting out of the inventory? I don't think anybody's looked at that.
Right. Could be
Right?
similar
So I
to-
think that could be a good way to at least start looking at some of those numbers and see how it varies from, for example, shale formation to shale formation. I expect it's going to be very different for Marcellus versus Permian versus Eagle Ford, Barnett, and so on. But I think some of those metrics, KPIs, need to be put in place before we will see the regulatory bodies taking action on those and try to really minimize the impact of this industry on the water cycle.
Great. Yeah, I think we have time for one, if not two questions.
Hi, my name is Charles Strohmeyer, and I work in finance and innovation, and I advise many different startups. My question is for Nadav or Lisa. In the past 3 years, I've mentored 3 water-related startups that have raised all their funding, the most recent being the Israeli firm Auto Agronom, which got acquired by a Chinese giant, Yuanda Enterprise. But I noticed none of these investors are water-specific investors. So my question is, for the water entrepreneurs in the room, can you talk some about your fundraising strategy, given that other than Liberation Capital, there's no water-specific investors at the early or later stages in the U.S.?
You want to start, Nadav?
Well, our A-round investors were clean tech venture capital firm, and there are a few venture capital firms in the world that are focused on water. XPV is one. Emerald Venture is clean tech, but a lot of water. GE Ventures have water investor. Aster European. So there is Virgin Green. So there are like probably 6 VCs in the world that have focused on water, and then there's others like Flagship, and I guess about 10 other VCs around the world that already had water experience, which makes them slightly more, slightly higher potential to actually go back and invest in water, at least by virtue of understanding the risk management part of an investment. And you know, I'm used to investors meeting, and the first meeting is always all flares, how great is the potential. The second meeting is always where are the risks. And as it gets closer to the deal, the risk is becoming the bigger factor. And so you need to find investors that can analyze it. Otherwise, it looks great when you start, but it will never end. So from my experience, there are some water startups, but they have been burned in the past. And many of them don't really want to take any risk. And at this stage, I think that many private equity funds and family offices might be a better ally to get finance. For early stage companies, it's probably mostly angels that will enable the companies to go to the next stages. Again, there are VCs in this market, but I agree, this is one of the challenges, and we all need to bring some success stories in order to take them on. Specifically about our company, and then I'll finish. You know, we have gone through the development of the company to the technology story through piloting and patenting and proving that it works in a pilot stage well before we made our A round. We took our A round investment. So I guess the only way to repeat this and bridge it is finding the ways to bring the early stage funding. From the other hand, what Oasis has done, came with a very good business plan and a good idea of flashing colors around the business plan and managed to raise $10 million from the first day. In terms of building a startup, that's a much better approach if you can do it. But for that, you need to bring the entrepreneurial expertise, which often lack in our industry. And I think that the right way is developing your technology to the maturest stage you can and bringing in this entrepreneurial experience.
Would you like to add to that, Lisa?
I don't have much to add. I guess the only thing I would say is that from a venture capital standpoint, if you're looking for a 3 to 5 year return, water is a difficult play, which is why you're seeing a lot less VCs in it. There are a lot that are just focused on just water for that reason. We got lucky as Oasis. We came in right during a time, actually we didn't get lucky, we raised in February 2009 when the stock market was just crashing, and we raised $10.5 million. So we did get lucky though. But by and large, a lot of people that want to invest in water, as Nadav said, want later stage companies. They want to see that you have 1 or 2 installations. They want to see that you've made some good groundwork, that you've vetted out markets, those kinds of things. So I don't know if I would have any additional advice other than there is certainly work that we need to do to make sure that we're successful, because success breeds success.
Great. And we will take one more question.
Hello, my name is Simon Chung from Gradient. From the presentation I've seen today, there are a lot of innovation going on in the brine concentration and also desalination technology. I'm wondering if any of you have seen some innovation happening in the pre-treatment steps, like in oil removal and stuff like that.
Yeah, so you're absolutely right. I can take it?
Please do.
Okay, so you're absolutely right. There's a lot of innovation on the lower cost brine concentration technologies, gradient, forward osmosis, membrane distillation, and so on. Where we think there may be opportunities to innovate is around, as an example at least, is if you have a water that's, for example, a produced water, where we talk a lot about these technologies as where the TDS, or the total dissolved solids on the water, are on the lower end, which can be managed or handled by an RO. We don't have all the right pretreatment and de-oiling technologies to take out the suspended solids in the presence of organics, be it XGR or DRO, all of those things, so that the water is good enough to send to, say, an RO system. So I think on the pretreatment, de-oiling side, there's opportunities to innovate and make the water clean enough so that it can report to a membrane system.
Great. That brings to the end our Water in Our Industries panel. We'd like to invite you all for a social gathering just outside when this all finishes. And I'll finish now by thanking the Water Summit team and also thanking our panel here for this final event of the day. Thank you very much.